Hi, this is Jason. Um, this is homework 3, question 1. So the question is the probability x equal to k is equal to b times k times p to power k minus 1. K is from 1 to infinity, and the p is between 0 and 1. And the question A is find the b so that the probability x equals to k represents a probability mass function. So for question A, we can see the probability of x equal to k equal to the b times k times p to power k minus 1. We know that the total probability k equal to 1 to infinity is equal to 1 since it's a mass function. And we know that so we can put the equation here. So we know like the p times the sum of b times k times p to power k minus 1 is equal to 1. So here we can see we can see here the k times p to power k minus 1 is equal to derivative of pk. So the b times the sum of the b times the sum of b times k times p minus 1 can be rewritten in this form: b times the sum of derivative p to power k, which we can also rewrite it in this form: b times derivative k to the limitation p times 1 minus p to power k over 1 minus p. Since p belongs to 0 and 1 and k is close to the limitation infinity, so we can see p to power k, since p is 1 between 0 and 1 to infinity is equal to 0. So here we can eliminate the k, since we already use it here. P to power k is equal to 0, and we can see here, so the equation becomes b times derivative p over 1 minus p. So here we need to do the derivative of division. So we can see here we first do the derivative of p minus times 1 minus p minus derivative of 1 minus p times p. So we got the final equation is 1 over 1 minus p to power 2, and we put this back to the equation, and we see b times 1 over 1 minus p to power 2, and this is the equation which is equal to 1. So here is equal to 1. We got b is equal to 1 minus p squared, and we can rewrite the formula p x equal to k equal to b times k times p to power k minus 1 is, we can plug in the 1 minus p to power 2 and we got the equation p2x equal to k is equal to 1 minus p to power 2 times k times p to power k minus 1. Okay, the next one is we try to find, question B is we try to find the expected value of x. So basically we know like expect value is equal to the k, the sum of, so we know that the probability and the probability x equal to k and times the k value, and the expecting value is the sum of them. Yeah, and so we can see here it's we just plug in the b, we put the b outside, and here we also start to calculate the, here we can see this one has become to k times b times k times p to power k minus 1. So this part is equal to this part, and we plug in, and we can see here since there's another k, so it's k times p to power k minus 1. So for this part we can see we can do that since this part is equal to the derivative p to power k, this part is equal to derivative p to power k. And we can plug in this part, and also there's another k here, so we can do the same thing. We just this also equal to derivative p to power k. So basically we just put another, for this at this step we just separate p outside here, and this one become another derivative of p to power k. So basically we just do this method again, this function this way again, and we put back to the equation. So we got the b times derivative of p times derivative the sum of p to power k, and here it should be k. And we can see for this part the sum of pk and the derivative p to power k, we already did that in the last question. So the derivative of pk is equal to we did it here, the derivative of pk and the limitation of this equation. So basically it's equal to 1 over 1 minus p to power 2. So we put the equation here. So this part is equal to 1 over 1 minus p2 square. And we need to keep doing the equation. So basically we put the p over this. Same thing, we need to do the division derivative, and we got we got this equation, and we can cancel this out. So basically, it's 1 minus p to power square 2 square power p 1 minus p square plus 2p times 1 minus p over 1 minus p square. So after simplify, we got the expect value is 1 plus p over 1 minus p. Okay, so we need to do the expect value x squared. So since we know like expect value of x squared is equal to sum of k squared times the probability of k, x equal to k. So we follow the same process. We plug in the probability x equal to k is 1 minus p squared times k times p to power k minus 1. And same thing, since we have the k times p to power k minus 1. So we can do the same thing, modify it to the derivative of p to power k. P to power k. And also we get why not b times the derivative of the sum of k squared times p to power k. So since here we still have k to power 2, we need to do this like twice, 2 more times, and here we do it 1 times, and there's another times. So basically, we finally get the equation. So it's the same thing. The dp derivative of the sum of p to power k is equal to 1 minus k, 1 over 1 minus p to power 2 square. Yeah, and this we need to plug in this equation, and we got this equation. So we need to do the division derivative twice, and after the derivative, we got this equation. And we can see it can be cancelled. It's 1 minus p to power 6. It can be cancelled, and here is another cancel for 1 minus p square. And final, we got the expected value x squared is equal to this equation, and after simplify is equal to p squared plus 4p plus 1 over 1 minus p to power 2. So we need to calculate, for question D, we need to calculate the expected value x squared minus expected value x to power 2. So basically, we already get the expected value of x squared here, and the expected value of x is we calculate in question B is 1 plus p over 1 minus p. So basically, we just do the calculation for this question. So we plug in for for both expected value. This one is this, and this is the expected value of x squared. So we simplify it as 2p over 1 minus p to power square, to power 2. Yeah. So the last question we give us the p is 1 over 3. The b is equal to 1 minus p to power 2, since we get this equation in question A. And we can calculate it as 4 over 9. And the probability x equal to k is equal to, after plugging in, is equal to 4 over 9 times k times 1 over 3 to power k minus 1 to power k minus 1. And we are trying to calculate the probability x equal to, given x is greater or equal to 2 and less or equal than 5. So basically, we know like it's a conditional probability according to this conditional probability. So it's equal to the p the probability of p times probability x equal to k. X is greater equal to 2, less equal to 5, less equal to 5 over the sum of probability x equal to k. X is belong to 2 to 5. Yeah. So the above part, we can use the equation. It's still the equation of the original equation we got here, and the only difference is the x, the k has a limitation interval. It's belong to 2 to 5, and both are closed. And the bottom we can calculate by one by one. So start from 2, 4 over 9 times 2 times 1 over 3 to power 2 minus 1. Same thing after apply to 2, 3, 4, 5. And here is 3, 1, and 2, 5 minus 1. And after calculation, we got it's 1 over 0.5377 times 4 over 9 times k times 2 times 1 over 3 to power k minus 1. 1k belong to 2, 3, 4, 5. And otherwise it's equal to 0.